So here's the first problem. It's going to be brewing tea in a cup. It is a mass transfer and a heat transfer problem. So we have all of our variables. For the water, for the mass transfer, where we're starting, it'll be in cylindrical coordinates. It'll be steady state or steady, and it will be going through. We have the mass changing concentration over the thickness of the tea bag, and we have the volume of our cup. That way we can calculate the mass. We have the mass being transferred, we have the volume of the cup, so we can determine it, and then we can find out where we got our concentration. Now for the heat, we're going to have two aspects. One, we're going to treat as a flat plate with natural convection. So we go through, we calculate the Rayleigh number, we calculate the Nusselt number, and then we calculate the H and the Q. And then we're going to do the same thing for a cylinder, and that will get us our temperature change at the bottom, which is fairly minuscule, but that's what we would probably expect for a tea brewing process, because the tea doesn't get super cold in like 2 minutes. And of course, everything here is natural convection, where the convection occurs, so that will be where we get our Nusselt numbers from. For our second problem, we have a scuba diver here, and we are going to see the amount of heat being lost by flight just as a skim-based average. And for this one, we will use Cartesian coordinates. We will have it as a conduction-based and convection-based, and it will be resistance. So with the resistance, we find the initial resistance, which is used by having the coefficient times the area. And then we have it solved through that. This one I solved through Solver. You could do the algebra if you wanted to. So you add on the conduction resistance, and then that should get you your answer here, a thickness of 1.17 centimeters. So for the second part, we have a dryer. So this will be forced external convection. We're going to treat this suit as a horizontal plate. And we go through the velocity, we have the props, we're going to find the Reynolds number, and that will get us the Nusselt number, and that will get us our convection coefficient. And then from there we can multiply that all together, gets us our Q, and then from that we can find the amount of time it will take for the suit to dry, or suit to reach temperature, which is 25.4.